Alright, so we're back with another day of geometric sequences. Today, this is going to be our main deal. Huge big man of the today. He's gonna be he's gonna be our geometric sequence formula, obviously. Anyways, before we start, unfortunately geometric series do not have such a cool backstory like the arithmetic one with Gauss. Yeah, unfortunately, it's like we kind of just learned this throughout the time. You know, we didn't knew this back then, and then at one point it just clicked, and it was like, okay, wait a minute, we can do geometric series too. So obviously, when I was a student, I learned this. I hated the formula derivation part, but thinking about it now, not really. It's pretty interesting to think about how the formulas derive because it helps you memorize it. So let's go ahead and start with the series. Wow, not writing clearly. So let's go ahead and start with the series Sn, and it can be represented by the first number, which is a, and obviously it's multiplied by a common ratio of ar, and it's multiplied by the same ratio, and da 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 all the way until arn. So how do we want to derive this formula? Well, you can see we flipped it and we added another one of it in the arithmetic one. So could we possibly do something similar here? So not really, but we could multiply something. We could do something so that we can actually minus it instead. So if we multiply the left side by r, we would actually now get ar plus ar squared all the way to ar n plus 1. Sorry. However, this is not a form, because hey, what can n be, right? N could be infinity, and infinity plus 1. What is it? What is that? You don't know, so we don't know. So we can the best we could probably write this as is arn, unfortunately. But however, there is this thing that's back. It always has one more than the other one. It always has one more, right? Because we multiply this, and if we want to minus this, these terms have to line up. So here, there's still a term. This could be ar minus 1, and at this point, it's also ar minus 1. And this is ar to the power of n, right? So now if we want to go ahead and minus this minus that going up, so we minus this, you'll actually go ahead and get a because you have nothing to minus a, but keep in mind that you're actually having negative a because, yeah, the signs, guys. And then everything, blah, 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 a plus ar plus blah, 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 all the way up until here. Everything lines up here, all right? Up until this point, everything lines up. Now, this is your problem. We still have one more term on the bottom. So that one has nothing to do. So we can't do anything, unfortunately. So the only thing we could do when we do this, I will actually write it out so it looks better. So rsn minus sn will actually go ahead and get us negative a plus arn, because we have one more term on the bottom. So now we look at the left side and we're like, okay, can I write this more algebraically? Sure. So let's go ahead and write it more algebraically. Okay, so let's look at both sides. Is there something I could factor from the left? And I look at it, yes, there is, of course. I could go ahead and factor the Sn out. So Sn r minus 1 is equal to arn minus a. And we look at it, wait, hold on a second. We already have it here. We isolated the Sn. We could literally just figure it out if we divide it, right? So let's go ahead and do that. Sorry. And that's it. That was our formula. And obviously, we could also take out the a at the top if you don't see this. If you have a little bit of factoring background, you should be able to see this. We could take out the a, and we could go ahead and have the a of r to the n minus 1 over r minus 1. And there we go. That's our big man for the day, and that's all we have to derive. So let's go ahead and use this formula to, well, obviously calculate the sum. Alright, that's 8. So this is pretty simple. So we're we're trying to find the 8th term. The sum until the 8th term. So n equals 8. I'll write smaller. And our common ratio we have, it's clearly 4. Our a is 2. Let's go. Is equal to a r n minus 1. Now remember, we actually have a restriction on this, guys, because this can't be 0. At the bottom, if it's 0, it's undefined, right? We all know that. Go ahead and plug in the values. So I typically recommend you to go ahead and write out the formula when you are doing these questions, simply because it really does help. But on the test, most teachers do not actually go into that meany-miny stuff. It doesn't really matter. 4 to the 8th power, that is great question. Alright, we'll just calculate it. Calculator work, let me calculate. 43,690. And there we go. So up until, as long as you're able to identify the formula, which you have to memorize. Some teachers give you the formula, which I think is pretty stupid, but hey, I can't judge how people teach. So sometimes you have to memorize, sometimes you don't. If you literally, as long as you have the formula, you should always write out the values that you have here and a blah blah blah, and then you're able to just plug it in. Alright, let's do the same thing for here. So a equals 3. R equals to negative 3. And we have 9 term. So as well, I'm gonna go ahead and write out the formula. Sn equals a r to the nth power minus 1 over r minus 1. Alright, so I'm gonna go ahead and plug this in. So 3 and negative 3 to the 9th power minus 1 over negative 3 minus 1. So at this step, there's no way for you to get it wrong. If you get it wrong at this step, shame on you. Anyways, this is 14,763. Guys, I could be wrong. So if you see something wrong, you should let me know in the comment section. Anyways, last one. So we look at this and we're not given the amount of terms that we have here. So we have to recall for some formulas that we did, last time. So t equals a r n minus 1 to figure out n. So the term is 2916, obviously. Tn is equal to a, which is 4, r, which is 3, to the n minus 1. Now, how do you go ahead and get to this, solving this type of thing? So you go ahead and do 2916 minus 4 first. This is 4 if you don't see it. Alright, so you will go ahead and do this. And then you will go ahead and obviously you will get 729. And there's 2 ways to solve this. You could log it, you could do this to turn it into a 3n over 3 problem, or you could do whatever. You could do the equivalence of base, I guess. So this is actually 729, that is 3 to the power of 6. And equals to 3 n minus 1. And note that your base are the same. So 6 equals to n minus 1. And then equals 7. Alright, we found all that out, and now we can actually use this. So S of 7, where n equals 7, a equals 4, r is equal to 3. What else do we need? That's it, right? Yeah. Sn is equal to a r n minus 1 over r minus 1. And it's equal to 4 r, which is 3, to the 7th power minus 1 over 3 minus 1. Note that whenever you plug in a number here, there's a bracket. So it doesn't really matter when you have positives, but it does come in handy when you actually put the bracket for a negative number, because could get different answers if you don't put the brackets. The answer is 4,372. That was pretty much done our series question. So the series question and the next unit, the series unit and the next unit, really for me, I think it's literally just a mark booster so you guys could recover after trig, because trig was it was a disaster for many of y'all. So yeah, it's a chance for you to recover. So make sure you do the homework, gets a lot of practice, and do some word problems especially. Not sure if teachers really test for that, but I usually do. So your homework is on 400 page, your textbook, McGraw-Hill. If you don't have it, you can find it online. It's on page 476, 477, 478. There's some word problems, and that is it for today.